Now, there is a non-algebraic approach to converting a repeating decimal to a fraction when the entire part of the decimal is not repeating. So here we have the example of changing 0.41 repeating to a fraction, and again, in this number, only the 1 is repeating, the 4 is not. So the steps we can take to convert to a fraction without writing an algebraic equation and solving and multiplying by 10 to the something and subtracting, without doing all of that, you could use 10 for every non-repeating digit. So here we have one non-repeating digit, so we're using 110. And we can use 9 for every repeating digit, and there was only one repeating digit of 1, so we'll use 9. So we're using 110 and 19, and we're multiplying those together, those 9s and 10s, to form the denominator. So 9 times 10 gives us a denominator of 90. Now, we can subtract the non-repeating digits from all the digits to form the numerator. So all of the digits in the decimal, we have 0.41, so those digits, that gives us 41. And then we can subtract the non-repeating digit, so in this number, that's 4. So we're subtracting 4 from 41 to give us the numerator of 37. And then we can reduce if necessary, but 37 over 90 doesn't reduce in this case. So using this approach, we could know that 0.41 repeating is equal to 37 over 90 without setting up an equation, without having to solve for a variable x. Let's look at another example. Here we have changed 0.13 repeating to a fraction. So we're going to use 10 for every non-repeating digit. So we have one non-repeating digit, it's 1. So that would be 110. We're going to use 9 for every repeating digit. Well, there's only the repeating digit of 3, so we're going to use 19. And if we multiply 9 times 10, that gives us the denominator of 90. Now, to get the numerator, we're going to subtract the non-repeating digits from all the digits in the decimal. So all of the digits, we're working with 1 and 3, so that gives us 13. And the non-repeating digit is 1, so we're going to subtract 1 from 13, which gives us a numerator of 12. So 0.13 repeating is equal to the fraction of 12 over 90, but that can reduce to 2/15. So 0.13 repeating is equal to 2/15. And again, we didn't have to set up an equation or solve for any variables. We just used this non-algebraic approach. Let's look at one more example where we have more than one digit that is not repeating. So just to show you for the denominator how that would change a little bit. So step 1, we're using a 10 for every non-repeating digit. So if we're changing, for example, the decimal of 0.916 repeating, we have 2 non-repeating digits. So we're going to use 2 10s as factors in the denominator. Now, we still only have one digit repeating, the 6, so we're only going to have 1 9 in the denominator as a factor. So the denominator will be 10 times 10 times 9, which will give us 900. We're still subtracting the non-repeating digits from all of the digits for the numerator. So all of the digits was 916, so 916. And the non-repeating was 9 and 1, so that would be 91. So the numerator is 916 minus 91, which gives us a numerator of 825. Reducing that fraction, 825 over 900, gives us a fraction of 11 over 12. So 0.916 repeating is equal to the fraction of 11 over 12. So you can use this non-algebraic approach if you can remember these steps, if you can see the pattern, or you can always fall back to the equation, an algebraic approach. Either way, you can convert these repeating decimals to fractions.